This is a production of Cornell University.
Well, thanks very much. Today I'm talking about reputation, neighbors, understanding the market for wine, and this work is, this presentation draws upon a lot of joint research with Marco Cosnigro, one of my previous graduate students who's now a professor at Colorado State University, and Nan Yang, who is also a former PhD student who is now an econometrician for Discover, and then some other colleagues. I also wanted to say thanks to Brad Rickard for setting this up, and also to Mark Smith and Bob Steams at Geneva. So I'm happy that some people are there to hear this talk. And so I will get started. Today I'll be talking about drawing upon some results from 3 papers. I will have a few equations in this presentation, but I promise not to bore you with deriving the details, just basically describe them in words. So I'll just briefly touch upon the equations. But what I'll talk about today is to model some producers' incentives to invest in quality when firms have their own private brand name, but they also share a common name and a reputation, which is commonly the case in wine. We'll discuss that some more. And then secondly, I have 2 empirical parts to this paper. One to estimate how names and reputation nest within each other to identify producers with increasing specificity and how that affects prices. And then finally, I'll also examine the spatial relationships of neighboring wineries with market data and use GIS with that. So wine is just a fascinating product. I think I got interested in it. I enjoy drinking wine, but I also find it a fascinating product that I love this quote from Robert Mundave, for example. One wine in the valley, and he's talking about Napa Valley, one bad wine in the valley is bad for every winery in the valley. One good wine in the valley is good for everyone. So the point is that wine is a class of products in which each firm wants to develop its own reputation for quality, and each firm wants its closest neighboring wineries also to produce the highest quality. So think about that. That's sort of different than a lot of places where where one firm wants to have be known for the highest quality and to be able to outcompete everyone. In wine, you want to be from an area where all your neighbors also produce high quality wines. Geographical indications from Europe may be another example, and I'll talk about possibly other examples. And so so we can think about maybe a quality cartel where there's a cartel where they can jointly choose quality would be the best situation from the industry side for this. So I'll get into reputation. So wine is something where your reputation really matters. So people buy wine based on what they think about it. And so I like this picture here with the woman in a wine store. Actually, this looks like Costco instead of a wine store, but where there's just a vast number of different wines to choose from, and it can be daunting to select the one that would be best. And so wine is an experience good, and there are 3 classifications of goods in economics based on information. One is a search good, where you have perfect information. The second is an experience good, where you can't determine the quality until after consuming it. And then the third is a credence good, and the credence good is something where even after you consume it, you don't know for sure what the quality is. And I've actually had people argue that wine is really a credence good because it's based on the marketing. So they can't verify, but the marketing tells them it's good. Okay. So but when quality is uncertain, ex ante you don't know what the quality is. When quality is uncertain, then both regional and firm reputations can play a role in consumers choosing a wine. And so because of that, consumers are willing to pay a higher price for products that come from high reputation firms and from high reputation regions. Okay, so now let's think about reputation. It can from the way that economists think about it. The broad definition of reputation is an association of a name to an expectation of quality. And reputations are latent, so they aren't directly observable. So we can't just, it's not something where we can have data just on reputation. We have to infer it. And it's also subjective. It's based on people's opinions. Reputation can have increasing specificity also. So you can have reputation for different things. And I have this example of the Russian Matryoshka dolls, where each one can nest inside each other. And so we see it here. This is BV from Rutherford within Napa Valley. And so it's interesting that there are reputations associated with all these things that I've circled. BV, reputations associated with the AVA Napa Valley and the sub-AVA Rutherford. So just a very small area within Napa Valley. There is a reputation associated with the year. You hear that's a good year for wine. They even list the winemaker on this bottle. And then reputation associated with the variety also. So I found this one interesting also, that Napa Valley is of course a California wine. California is not listed on this bottle, so they're drawing their reputation from Napa Valley and from Rutherford rather than California. So then let's talk a little bit about how market characteristics affect reputation and how reputation affects a product. So what I'm going to talk about here is mainly between firm reputation, collective reputation, or a combination of both, and how that depends on the characteristics. So markets that have collective reputation only, so it only depends on the region you're from, let's say, some examples of that are non-traceable firms with a recognizable region of origin. And so coming from Washington, I would give the example of Washington apples. So there's many producers, and when you buy a Washington apple, you don't know which farmer produced it. You only know it came from Washington. So that's an example of non-traceable with a recognizable region of origin. Then there are markets with firm reputation only, and so that's a traceable firm. You know which firm produced it, but you don't know, but the location is irrelevant. And so an example could be firms delivering services, or an example I like using is Starbucks. Okay, so Starbucks, it doesn't matter if you buy it in New York or Washington or anywhere in between. You get the same coffee, and it has a reputation for the quality of the coffee it makes. Then next we have sort of this what I've been calling a dual reputation structure. So reputation with both firm and collective reputation aspects. And so with that, you have traceable firms, so you know who produced the product, and the location is also relevant. So an example here, I list the example, this is another Washington example, but Leonetti's wines in Walla Walla, Washington. So Leonetti's is sort of a cult wine, and it's really hard to buy it. You have to be on a waiting list for 3 years even to buy it. And then Walla Walla has a reputation within Washington State as a better wine region. You might also consider, for example, Honda and Japanese cars, although maybe we need to go to a different example from that now. But okay, so I thought thinking about this, I've had some people say, well, does this apply to anything else? Does this only apply to wine? I thought, well, this actually applies to universities. Okay, so I can say, so the analogy with wine, with this dual reputation structure, you can have, instead of the state for wine, we have the university, so we have Cornell here. And the American Viticultural Association, instead of that, we have the academic unit, so applied economics and management. Instead of the grape varieties, we can say field, so the field of development economics, for example. Then we have faculty members, and then the vintages are the PhD graduates. So I have Scott Rozelle, Jos Winnen, Susan Offit, and Travis Liebert. And then we have these quality measures too, even. So we have rankings, awards, and placements of your students. So I was thinking that's another way that so this model doesn't only apply to wine. We can think about other examples also. Okay, so let's move on. I'll quickly go through just talking about previous findings. The first paper that really talked about this was Landon and Smith, and they looked at Bordeaux wine, and they found that consumers rely more on reputation than on current product quality. So lagged quality was more important than current quality in estimating the market price of wine. There's been a number of studies that find a premium or quantify a premium for a region of production. A lot of them have been in wine. There have also been some studies on geographical indications, and I've done one, for example, but they find that the geographical indication is also important. And then I would put, also related to this are these state agricultural products, so Arizona grown, Jersey fresh, or Washington apple. So all these state promotion products projects are also similar to this, that they're trying to promote the state and give a collective reputation for the state. Well, so now theoretical literature, the study of reputation really goes to the early 1980s. So Carl Shapiro and then Krebs and Wilson, and they did these studies of firm reputation. So for example, Shapiro has a dynamic model and finds that it's necessary to have a price premium in order to justify an investment in quality because of the lag. If there weren't a lag, then we'd have low quality. And there have been a lot of studies on this. Then Tirole out of Toulouse in 1996 first coined the phrase collective reputation. And I just thought this was, so I was in grad school at the time, and I just thought this was fascinating, collective reputation. And so, but Tirole did something very differently than the way I'm thinking about it. He used a matching model, and he talked about collective reputation of a group of workers, and also describing the persistence of corruption. So Tirole's idea, and this is sort of a funny, I'll tell it quickly, story that for example, if you are a member of a crime family, like a mafia, okay, and you want to earn an honest living and go straight, because of your association with your family, everyone's going to think that you're not going straight. So you might as well. So that's Tirole's. That's what Tirole talks about in this paper. Then one of my graduate students, Jason Winfrey, and I had a paper in AJ in 2005, and we looked at collective reputation as a common property resource. So for graduate students, in economics, I would recommend, it's always, I think it's nice, I did natural resources in one of my PhD fields, so I thought of, well, collective reputation is just like a forest or a fishery, that it's a common property resource that people want to extract from. And so that was sort of our idea, and I'll talk about this just a little bit more on one other slide, but most of the literature either focuses on private or collective, and in many instances there's a dual reputation, so both exist, and especially in wine. And there's also a new literature that's forming on geographical indication, and a recent paper is Menapise and Giancarlo Moschini that was just published last year. Okay, so my first paper in this that I got started in this is with, as I said, with Jason Winfrey. He's now a professor at University of Michigan, and we looked at, we were looking at there was a lot of people griping in the apple industry that apple prices are low, and consumers were saying, oh, the eating quality is bad. And so we found some empirical evidence that reputation was declining, trying to estimate it as a latent variable. And so we were thinking of, well, why is that? Why is it falling over time? And so you can think about it as a dynamic problem similar to a natural resource. So if it's a common property resource, then firms have the incentive to extract too much. And so they extract by selling low quality products at high prices and free riding on the group reputation. And so it's just like a common property resource, their shadow price is too low, and they extract too rapidly. And so this was sort of a new way of thinking about collective reputation. And we could show that as the number of firms increase, then the collective reputation decreases into an equilibrium. And so this actually, the sort of interesting thing in this is that it provides an argument in favor of quality standards. And I've talked to some lawyers about this, and that they're typically argued as antitrust, that you're trying to keep a small number of firms in the market. And so that's why you'd have quality standards. But we're saying, no, you're trying to protect your common brand. Okay, so I'll move on to the model. I'll briefly talk about this model. I know I don't have a lot of time, so I'll try to go through this pretty quickly. But we have N risk neutral producers in a production district, no entry. So you can think about it that people own land. So that's the barrier to entry. You have to own land to have a vineyard. Okay, each is maximizing his net present value over an infinite time horizon, and it's subject to the evolution of both regional and firm reputation. So we have two reputation, group and firm. And all firms produce a fixed constant quantity, but they choose their quality level. So you can think of the quantity is normalized to 1, okay, and based on the land size. And And the firm and collective reputation in each time period are Markov processes, so they evolve over time, which are partially controlled by the producers. And so reputations are a function of past quality, just like you'd expect. Prices are a function of reputations. And then, and also the presence of a collective reputation implies that firms in the productive region share comparative advantage relative to the firm outside the region. So you can think of terroir. Okay, so if you're in this region that's really good for growing wine, you can grow better wine. Okay, so as I said, I would have some equations, but I'm just going to point to what they are. So here we have you're maximizing your net present value of profits over time, price times a unit of 1, and price is a function of firm reputation and collective reputation minus the cost, and the cost is a function of quality. Okay, subject to a state equation for reputation, so how reputation evolves over time. So reputation depends on past reputation, and then this is the change. So we have current quality minus the past reputation. So if quality is greater than reputation, then this will be positive. So reputation will increase, just like you'd expect. If quality is below reputation, it will decrease. And then here I can talk about this a little bit more, but this is the speed of consumer learning. So how fast they find out about it, how big the time lag is, and then we also have this firm visibility parameter. So if you're more visible, then you'll have a bigger effect. So first I'll go to this one. This is the state equation for collective reputation. So reputation, just similar to the other one, depends on past reputation, and then we again have this difference between quality and reputation. And all this stuff is right here is that we allow for different weights for the firms. So we might say that if one firm is bigger than the other firm, then they have a bigger effect. Okay, and then this last one, this is a dynamic game. So this last one is just the transition equations of the private reputation of firms, as well as the state contingent choices of quality, so that each firm is maximizing depending on everyone else's choices. So it's just the normal game theory approach. Okay, so then we do allow, so in the paper, and I left a sign-up sheet for the paper. I can email anyone the paper, but each firm observes private and collective reputations and anticipates what each firm will play in a NAS strategy subject to the evolution of the complete system. We have speed of consumer learning that's between 0 and 1. We have a firm visibility parameter, and then we allow for different weights, and if and they have to be greater than or equal to 0 and add up to 1. Okay, so then I won't spend a lot of time on this, but we have in simultaneous Bellman equations to solve this system, and it's sort of a complex system to solve. We first solved it analytically, but you have to make all these severe assumptions. So we decided to simulate it, and so I'll talk about the simulation results. And the simulations are we do that by parameterizing it with California wine data. So instead of assuming a lot of functional forms, we utilize California wine data to estimate the demand and how reputation affects prices. We use observations from the Wine Spectator magazine that spans 10 years of vintages, and that includes blind tasting scores, and we're only looking at red wines. And the Wine Spectator ratings are used as proxies for quality. They're blind quality assessments by experts, and we think that they're exogenous to prices, so the experts don't know what they're tasting and they just rate them. And we can debate whether that's a good proxy or not, but that's what we used. Each observation includes the producing winery, the rating, the American Viticultural Association area, the vintage, and the price, and it's in $2,003. And then we estimate a hedonic model with quantile regression in order to capture the changing structure of reputation across price segments. Okay, the cost side. So as usual in economists, it's always hard to get cost data. And so what we're interested in the cost of quality, of providing quality, so in terms of these ratings. So we just calibrate a cost function that's a linear marginal cost to get quality. And so and what it's basically doing is so that we can solve the system. And so this allows a numerical solution to the problem, as well as offering a first order approximation to the underlying cost functions. We're not defending this to the death or anything, but this is how we solved it. So just a discussion of the theoretical, quickly, of the theoretical results with homogeneous firms. And we do, in the paper, we consider lots of different variations on this, but I'll just talk about in terms of homogeneous firms, that investment in quality is increasing in own private reputation, in other firms' collective reputation, and in other firms' reputation and collective reputation. And so this implies that a decision by another agent to invest in quality induces similar behavior. So in that dynamic game by other agents, and it's primarily through the price effect in the collective reputation. And so this is what we expected, but it's nice that the calibrated, that the simulations also gave us this, that under this dual reputation structures, returns from private reputations mitigate the free riding behavior that we found, that Jason Winfrey and I found in that collective reputation problem. So it mitigates some of that associated with the common property resource of reputation. And then so then another interesting aspect is that the equilibrium quality and reputations increase from the low to high conditional price quantiles. And we'll talk about that a little bit more in more empirical results. And so what this means is that higher price segment producers capitalize on greater returns from investing in quality. Okay, I want to just quickly compare cases. So I'll talk about 3 cases. First, a regional planner. So this is if there was a regional planner that could tell everyone what quality that they would produce. So sort of a quality cartel where everyone was told exactly what quality to produce. So, and this would be, so this is sort of this is a special case they'll invest in the sort of optimal quality. So you can almost think of it as a quality monopolist or a cartel. They'll invest in the optimal quality so that the marginal cost of investing for each firm equals the discounted marginal benefits to the industry. And so they'll include the total contribution to both private and collective reputation. Then so this sort of intermediate case that's probably actually the case in the industry, in this dual reputation strategic game, each firm considers the marginal value of his own reputation and collective reputation, but the positive externalities that are accruing to other firms are not internalized. Okay, so there's a little bit of a loss from the externality. And then in this final case, collective reputation only model, the marginal benefits are smaller still, so you'll have the lowest quality in this final case, and because of the inability to influence private reputations makes further underinvestment in quality. And so this is the public good. This is the special case, the public good problem that I looked at for washing apples. Okay, so then to talk, there's a related paper that we do more empirical work on. This was published in AJE with Marco Castanigro, and we added one of his colleagues at Colorado State, Chris Gomans, and in this one we wanted to look at how we estimated a hedonic model for wine as a function of product attributes and reputation with quantile regression, and one of the key things that we're doing is that we consider past quality, consistency of quality, and name longevity in this. So what we do is that we're interested in how names and reputations nest within each other to identify producers with increasing specificity, and we find, and one of our findings just up front is that the premium for good names migrates from collective for the lower cost to specific for the higher end. And so I'll show you some of the results from this. I think these are some pretty interesting results. These are quantiles, so this goes from it's from the 20th to the 80th quantile. So the lower cost wines are down here, and these are all wine spectator wines. So there's no jug wines or bad, low quality wines. It's all better wines. But we go from the 20th to the 80th, and as we see here, we have this is AVA pass quality. So this is this is sort of the collective reputation that you can think about. And so the collective reputation goes up, but it's pretty flat. And we can see that for the lowest quality wine, it's the most important, okay? And then this is the firm pass quality, and the firm pass quality is less important for the low-cost wine than the collective reputation. So firm reputation is less important for the lower-cost wine. And then we see at about the 70th quantile, it crosses. So we see that and it's going up pretty well. So we see that as you get to more and more expensive wine, then people care more about the specific wine than about the region. You can think about that maybe in your own experience. So if you're just buying like a $8 or $10 bottle of wine, you might look at, oh, I'll buy one from Australia or something like that, or I'll buy a New York wine today, and you won't. But if you wanted to buy, let's say, a $50 bottle of wine, you'd be more careful about who the firm is that you're buying from. Okay, and interestingly, the current rating for the wine is actually below the reputation for the whole spectrum. And then I also have consistency, and this is based on standard deviation of quality. And so we're interested if how consistency, or if we have a bigger variance in the scores over time, how that affects the price. Yes.
Can you explain the vertical axis? I'm having
Oh,
a hard time getting
okay.
into issue.
Yeah, this is
That's like 50 cents.
premium. These are premium for an increase in each score.
Each score.
Each
Okay.
increment of score.
Okay.
Okay. Yeah, and so then this.
So we have negative premiums.
Well, okay, so this is consistency. So it's actually the standard deviation. So smaller is better. Okay. So so explaining this. So if as the standard deviation gets bigger, then it's less consistent. Okay, and so so maybe I should have measured this a different way, but it's sort of the mirror image. Okay, so for the AVA, if you have an inconsistent AVA, so it hurts more than the firm, and then it's interesting that it's almost at the exact same level that at that 70th percentile that it crosses in the firm consistency. So if a firm is not consistent, it hurts more for the more expensive than the lesser expensive. The other thing that we were interested in is firm longevity. Okay, and so if people value that a winery has been in existence for a long time, or an AVA is an older AVA, so we're thinking about establishing a reputation in a new AVA versus an old AVA. But so what is sort of interesting is that AVA longevity is pretty flat but slightly increasing, and firm longevity is actually, it's not consistent, it's not different from zero, but it's slightly negative. And so we were thinking about that. So why is that? Because we would expect it to be positive. And the thing is that a lot of the old wineries in California were established around Prohibition, and the older ones, and they actually have a bad reputation to overcome. So that was sort of interesting. So think Gallo, for example. So jug wines, and then now they're trying to produce better wines, but I actually think that they have to overcome, the grandchildren. The grandchildren of Gallo are actually about my age, and they want to be winemakers on their own, but they have to overcome sort of this jug wine past that they had. So I think that's sort of an interesting. That's how I was thinking about it, at least. So, but I'll.
Jill,
Yes.
Back to the data against. I'm trying to understand so you have the wine spectators scores.
Yes.
9,000 observations.
For, I guess I get a little bit lost on what the standard deviation is of.
Yeah, so I will. It's based on a moving average, and I'll give you the paper. So I'm not going to go through that. It's not an exactly standard deviation, but it's a calculation that is a standard deviation like variance over time.
So for AVA past quality, that would be all wines
Average.
in that
the average.
particular point in time
Yes.
across the.
Yes, yeah, so we average of all the wines that are listed in Wine Spectator, so it's an average of the ABA. Okay,
Thank you.
all right. So just a bit of discussion on this. We see that the price premium migrates to become more specific as you get to the higher, more expensive wines. And so we were trying to explain this effect, and we were thinking that search cost increases as you learn more about specific wines. And so as if you're just buying a cheap wine, you might not, it is not worth your time to search to know about all the cheap wines, to do all that research. But as you are making a bigger investment, say $100 or $80 to $100 on an expensive bottle of wine, you are going to research and want to make sure that you're not wrong. So as the cost of being wrong increases, you increase your search time that you put into that. So that's our idea about why it migrates.
Yeah.
Yes.
One quick question about the search cost, because the literature on search costs have the number of brands or the number of SKUs,
Yes.
the wider the assortment, the higher the search cost. Do you, I don't know the paper, but do you look at that over time? Because there is a huge, increase in the number of different brands competing for the same.
Yeah. Okay. So we
But I don't
only.
know if that's relevant to your model, but
Yeah.
because we talk about search costs. Is that relevant there or no?
Well, we're only looking at 1991 to 2000, so we're looking at the decade.
Okay.
And there are just a lot of lower cost wines, and there are fewer wines as you get more expensive, and so there are just a lot of wines, and if you researched every one, it would be costly. And so instead of trying to find out about each brand, you might just use the collective reputation, or say, I think I'll buy one from Napa, that's in this price range, and do that instead of researching each brand of wine. But I think it is something that I'd like to look at more into, that how people about search cost and quality, and across price segments, because I think there's something there that could be interesting. Okay. So then lastly, I wanted to also talk about spatial relationships, and so that's sort of related to this idea. And this is what I worked on this with. This is still a working paper with my student Nan Yang, and then although I used GIS in my dissertation, I feel like I'm a little rusty with all the GIS stuff, so we added Mike Brady, who's my colleague at Washington State, and he's a GIS expert, so to make sure everything is up to date in terms of the GIS. So there have been findings that rating scores and prices are spatially related. Why? Okay, it could be collective reputation that we've been talking about. It could be a tasting effect or word of mouth. So here's a map of the Tri-Cities in Washington, and it's a wine map. So you can see that people go on tasting trips, and they might go, for example, up into an area where they can taste at eight different wineries. And so if you're located to a really nice winery, more people will go, people will talk about it. So they might be spatially related because of that. And then finally there might be production and knowledge externality. So the terroir, for example, that you might have, there might be better growing conditions and soil conditions and drainage for the production. And there could also be knowledge externalities. So I know in the Napa Valley they used to meet and just discuss how to make better wine in their valley. So the growers used to meet, and I could say too, I'm not talking about the cost side, but there can be cost benefits to being located close to each other also. Okay, so research questions, again, you guys are probably getting tired of the Western wines, but we're looking at California and Washington wines. And we're interested in the spatial interactions among wineries that are in close proximity to each other. And so we want to try to figure out what's the nature of the spatial relationship, and how can we best model and estimate this, and what is the value of being located next to a high reputation winery? So does that affect your reputation? Okay, so this is, to our knowledge, this is the first study to consider the spatial effects at the winery level. A lot of studies have just had dummy variables for regions, but no one has actually used GIS data at the winery level. And so this adds to the hedonic literature in wine by including these spatial interactions. And our results do suggest that there exist externalities and spillover effects in the wine industry, so that they are spatially related. And we might help a potential wine investor in their decision selecting a winery location. So we use GIS data, geographical information systems. We have, so my student actually found the location of all the red wines that are listed, of wineries that produce red wine and are listed in Wine Spectator. And here we have, and the Washington one didn't actually show up, but we have, this is coded by score, but we have California wines, and then I have the Napa Valley, Sonoma Napa sort of taken out here. But we have a GIS program, and we get the exact latitude and longitude of all the wineries in these states, and we threw out wineries that we didn't have that we couldn't get an address for, and so we have 79 wineries in Washington State and 876 wineries for California that we could get an address for, and that are listed in Wine Spectator during the years that we have data for. Okay. So similarly for each winery, our observations include price. I've already sort of talked about this, rating score. We have cases of production, year of aging, and region. And the continuous variables in this study are average across varieties and vintage for each winery. So each winery just has one score, and it's an average. Okay, because otherwise you don't want a winery to be its own neighbor, you know. Okay, so this is hard to see. Looks better on my screen. But these are descriptive statistics for the non-binary variables for California and Washington, and you can see that California does a lot better than Washington. And so here we have price and we have score. So the median price is of these is $23, and for California it's a little bit higher, $25.58. But you can see it starts diverging on the higher end. So the 75th percentile for Washington State is almost $30, $29.75, and for California it's $38. So California is a lot higher, and I do have the maximum for each. So the maximum for listed in Washington is almost $60. It's over $1,200 for California. So. I think actually Washington has higher wines now, but back then, higher priced wines now, but back then it was the highest one was $60. Okay. So we have score, number of cases, age, and then we use macro regions of production, not the AVAs, just macro regions. So Napa, Bay Area and Central California, Sonoma, South Coast, Carneros, Sierra, Foothills, Mendocino for California. And then we use 4 macro regions for Washington: Columbia Valley, Napa Valley, Walla Walla, and Puget Sound. Okay.
Is there a particular reason why you didn't use the
AVAs? Because of observations. You know, because we didn't, since we average everything, we don't have that many observations, you know, to have all those AVAs. Yeah. Okay. So there's sort of 2 approaches to spatial modeling. One is a spatial lag model and one is a spatial error model. And so we decided to use the spatial lag model and rather than the spatial error model. So the error model says that the relationship, the spatial relationship is in the error term. We're saying that it's in the main part, so it's not in the error term. Okay. And so now we have to figure out functional form. I won't talk too much about this, but we want to, so what we're doing is we have a spatial light parameter, that's this row here. Then we have price and we need to figure out what the best spatial weighting relationship is. So this is a vector of prices. It has the other prices too. So so what sort of weight we want to have there. And then we have the other variables in the error term. And so I think let me see if I have this in the next slide. So what we decided, we could have this as, we could have something like we could have a distance formula. So we could base it on how far the neighbors are, but what we decided to do, we thought that would be, distance would not work as well, but we might still explore that. But what we decided to do is have the criterion of the k nearest neighbors, so that some number of nearest neighbors affects your price, and we would determine that empirically, okay? And then we also did I'll talk about that a little bit more on another slide, but we also did a Box-Cox transformation to get the best functional form between in the hedonic price relationship. And interestingly, they're different across California and Washington. So in Washington State, it's just a semi-log, so log of price is the best fit with the functional form. And for California, it's a negative exponent to the negative 0.25 is the best fit for California. And so because of this, in interpreting the marginal effects, that you'll have opposite signs, okay? And I'll talk about that a little bit more. But then, so what we estimate is this transformed price times the spatial weighting relationship, and then the variables we include are score, cases, age, and then regions. Okay, so we explore the spatial relationship a little bit, and we use the Glober-Moran's I statistic, and we find that both price and score for both states are positively related to each other. Okay, so there's positive clustering at the global level. Price clustering is stronger than score clustering, which is, I find that's interesting, that that there is some sort of perception or economic effect that this measure of quality is less correlated than price. We estimated, so when we first did this, we estimated, as I said, we used nearest neighbors for our spatial weight. And when we first did it, I said, let's try 1 to 5 and see where we get a maximum, because I was thinking, oh, there'll be, it won't be that many neighbors that will affect your price. And so for Washington State, we got the best value at, and we used the AIC statistic to choose it. But for Washington State, based on the AIC statistics, the 3 nearest neighbors best give us the best fit. But then for California, we had the best fit at 5. Okay, so that makes me worried because that's on the boundary. So I said, just keep going, until you, until you get one. So my poor PhD student, I had her estimate out till 65, and she found that the best for California was 35. So, but what sort of, so I mean, maybe this is saying to do more work, but also what is sort of interesting is I thought that the number of wineries in California is about 11 times Washington. So I just said, let's see what percentage that is of the wineries. And so interestingly, it's 4% of Washington and it's 4% for California. So I probably do need to do some more work on this, but I thought that was interesting that, okay, at least that's consistent. So we estimated, I'll show you the results with just the k nearest neighbors and then without any spatial term. But the statistics we did Wall, likelihood ratio, and Lagrange multiplier tests all confirm that the parameter describing, so the row parameter describing the spatial correlation is statistically different from 0 and has a positive sign. And so neighbors do have a significantly positive effect on own price. And so definitely adds value. Good neighbors do add value, and that's not surprising on the price side. So and I suppress the macro regions. Here's our results for California and Washington. California is raised to that negative exponent, so the marginal effects. So you'd expect the positive sign, except for the rho, because the prices are transformed on both sides. So pretty consistent that we have this 0.33 parameter, very significant for both, and we get greater explanatory value. It's a better model when we consider the spatial. Sort of interesting to think about that the spatial part then makes the other parameters, and we have all the expected signs that we get in the other parameters. It diminishes their effect for all the other parameters. So just some interesting, just exploring how neighbors might affect wines. So the conclusion from this is that we find that reputations are attached to states, regions, and project names. There is an incentive to free ride on the region reputation, but it can be offset to some degree by incentives to improve your own firm or brand reputation. Reputations can have different effects on price quantile, and we have the search cost explanation that we might want to explore some more. The spatial estimations provide some additional evidence that high-performing wineries have significant and positive effects on wineries' prices for both states' wineries. But this, I have to warn, we always want to make our work relevant, to wine producers. I have to warn that this doesn't necessarily mean that choosing a location next to a high reputation winery will generate the maximum profit, because this is only focusing on the market side, not on the cost. So it could be that it's already capitalized into the land prices. Okay, for one thing, So, and then another thing, we could also even think about this in a dynamic sense that over time you might get the gentleman vineyard owner who doesn't really know anything about wine but has a lot of money, who's just trying it out, and you could see falling quality over time. So then I want to talk a little bit just about future research. So first of all, I did have a reviewer on so the first paper in the model, just the model paper it's forthcoming now, but I had in the Journal of Ag Econ, the British Journal, but I did have a reviewer say, well, this is really just a credence good, and you need to address that. You need to model that it's a credence good. And so I was thinking, well, that's another paper, that's not something I can just do, but it is an interesting issue that if consumers can't really judge quality, then wine might be a combination of an experience good and a credence good based on marketing, and credence good based on marketing and related to perceived quality and reputation. And so I could explore that. I've thought about this a little bit. I do have a theoretical paper on this, and I also look at credence goods in terms of in a game theory model for organic foods. So I think it would be an interesting thing to think about. And I just looked at credence goods for a single firm, but it would be interesting to think about in a collective or a dual reputation. And then another thing that is interesting is how do new reputations form? And so this is what I'm working on with Brad. So to give a plug for our research, we're doing a experiment starting tomorrow. Brad has an SCRI project on new wine regions, and so you guys have probably all heard either me or Brad talk about it, but we're using auctions from California, Oregon, and Virginia with different information treatments, no information about the regions, and then tying the region to an associated region in France. And we're thinking like reputation spillover. So if it's similar to France, how will that affect the valuation for the new wine? Then another thing that I'm sort of interested in is thinking about networks and reputation. So I think network economics is really interesting. So, and you could have applications. It could be interesting to think about university faculty and doctoral programs. So we keep all sorts of data on ourselves. So wouldn't that be interesting to go more into that? So going from university faculty to cattle auctions, I was just talking to I'm forgetting her name at the moment, but at a recent conference, a woman from Texas A&M, and she was talking about that the large operators would receive a higher price in the cattle auctions than the small cooperatives, and then so those small cooperatives formed together and certified their cattle, and then they got prices that were indistinguishable from the large operators. So I said, let's team up. So I like your data. So that might be something that I'm working on in the future. So with that, I finished. I was actually worried about that I wouldn't be able to squeeze it all in, so maybe I rushed a little bit too much. But I thought this was funny. This is a picture I gave. I gave a different talk on wine at UC Davis a few years ago, and Julian Alston brought wine for everyone and got their permit, I guess. So I had thought about bringing wine today, and some very wise gentleman from coffee said, ask for forgiveness instead of permission, but I guess I wimped out, and we just have cookies. So without any questions.
Yeah, I think if anyone has any questions for Jill here or in Geneva, if they can turn their mic on or off if they ask questions. Looks like someone's standing up. Maybe Jill, we can go there first.
Okay, and I can turn I don't know if we want this off. So yes, a question from Geneva?
Yeah. How do you account for variation that might be related to wineries which have one business address, which could be, say, Modesto, but are making varietal wines or AVA delineated wines from multiple areas? How does that influence your data set and your conclusions?
Okay, that is a concern. I need to. There are regulations about the percentage of wine that is from a region to be labeled as that region. I think it's something like 80%. But that said, it is not necessarily tied to the actual address. So that is a concern. I only have I do have a variable for estate wines, which means that it's grown right on it's grown at the winery, but the data is limited on that. So I get that is a drawback of my work. So I've thought about that, and I've thought about that it could be, maybe it shows the marketing effect even more, that maybe the terroir doesn't matter as much as the marketing effect of that location, that if you're in this great location next to high profile wineries, it is positive. I don't know if that satisfied you, but it is a drawback, and I probably should have discussed that actually, that we can have wines that are from different locations that are sold at a different address. They source their grapes from other wineries or other vineyards. Yes.
When you considered the location, a high-profile winery, did you consider the quality parameter or score parameters of those others located close to that, or is that not a variable you look at? In other words, your high-profile wineries, larger producers, I assume, with higher scored lines or a longer history of scores, and then the new ones located nearby, was their reputation based on scores considered in that comparison at all? Like if you have high-profile winery with new properties that are making high-scoring wines versus new properties that are making low-scoring wines, was there any?
So we didn't in this. Well, initially we just explored the spatial relationships for both score and price, and we found the higher relationship, or the higher correlation with price, and then we just looked at spatially with price. We did not consider other scores. We have the score of the own winery, but not the scores of the other wine. But that could be done. That's interesting. I didn't really think about combining both spatial aspects in the same. Yeah, I'm trying to think of how to do that actually. Yeah. Jerry.
Okay, I'd like to get the audience thinking about some of the differences between, well, you highlighted Washington and California. In the situation of New York State, I'll kind of ask you a question first to draw this out a little bit, thoughts out. When I go down to the north side, very well stocked, one of the best stocked, most labels, many stores. I've been there a few times. I have numerous selections of wines from California. There is one shelf for northwestern United States, and there are a few wineries for Washington and Oregon. If you go to a well-stocked wine store where you live in Washington, how many New York wines can you select? And I'll tell you a few rough figures. When we do studies in New York, we find out that way over half the percentage of sales of their wineries come from the tasting room. And I'm wondering how this influences your model and how we might look at it in the development.
Well, I think it fits the spatial model very well, you know, because that if your closest neighbors are good, I think that you'll visit those wineries more and you'll buy more, right? So
is AVA the right thing to look at, or is maybe wine trails collectively?
yeah. Well, so in this one, in this spatial model, it's based on nearest neighbors. So I think AVA still does matter, still does have a positive effect, but maybe the neighbors are more important for New York. You know, so the spatial. So it'd be interesting to get New York data and see if it's different, because it probably is.
Can you separate wine trail sales from wine store sales?
And we'd probably have a different weighting matrix too. So that'd be fun. It'd be fun to look at and see and compare. So, but we'd want to have you know, white wines also. These are reds. You know, so it's.
Now I wonder how many average New York consumers can even talk about AVAs. I don't know. Maybe somebody else wants to opine about that. But.
We're riding on Finger Lakes APA, Finger Lakes now, we're not really doing a lot of subcategorizing yet, because I don't think we felt there's consumer pull in that area. And I mean, I'm speaking from one winery, but you don't see Seneca Lake, even though it is an APA, on a lot of labels, even though there are lots of wines that we fit that. We're using
That's
further out.
yeah. That's interesting.
Is there any questions of Geneva? I just had a comment and a question.
Okay.
And I noticed that you and me and everyone who does this, we always use the wine spectator scores. And have you ever seen anybody use other, like the wine advocate scores or the wine enthusiast scores? I'm just thinking about that. If how much our results hinge on these particular set of scores we always use. That's just a comment. And then my question was about these AVAs, and when we use these time series of AVAs, the whole notion of AVAs is actually quite recent, right? The first AVA was 30 years ago, and there was 1, then there was 50, now there's 200. And in the course of some of your data sets, you know, one AVA became more than one, or sub-AVAs developed inside. Do you control for that, or do people control for that when they're looking at this question of AVAs over a time series, and as AVAs change, or do you just stick with whatever you had at the start and follow that and see that through the data set? Does that make sense?
In our data, we have observations for each AVA that we use for each year. So we have 10 years. No, so I wonder what the growth in AVAs was in California and Washington from 91 to 2000. So it might be before the huge upswing.
Right.
So
Inevitably there were more in 2000
yeah,
than there were in 91.
yes,
but,
yes, yeah.
But I don't know how to. And if you find a wine that's a new AVA in 2000 that wasn't even an AVA in 91, you just sort of put it back into one of the AVAs for which it would have been in 1990.
So we're trying for consistency. I'm trying to think of, we probably don't have all the sub AVAs in there, you know.
It's
So
not like these appellations in Europe that have been established for
yeah,
years and years and haven't changed.
So we have Napa, for example, as an AVA, and we might not have all the sub-AVAs, use those. So we're using more of the bigger AVAs, and that's probably better for our analysis.
Yeah, I see. I like these macro agents because things can happen within the
Yeah.
macro agent and still use it as an
Yes,
identifier.
and Wine Spectator, so we do sort of lean on Wine Spectator, and it's a nice data source, so so as economists, it's always good to have data, and they have electronic versions of the magazine, and they have all the data that you can ready to analyze, so we have the price, we have the cases produced, there's all sorts of data that you can use and do a lot with. So with that, there's been a lot of work on wine economics, and hence a journal of wine economics, and so it's easy to obtain data, and you can try out new things, but it might not be the best, but you have to choose one, right? So I don't know if Wine Spectator is any better than Wine Enthusiast or Wine Advocate, but you have to choose one, and this one is all already electronically available.
Right.
This has been a production of Cornell University, on the web at cornell.edu.